Hi folks, today let's try to do this group anagrams problem on Leetcode. It's a very, I would say, kind of interesting problem which exercises our brain for the use of hash maps and things like that, I would say. So it would definitely be an interesting problem to solve. So let's give it a try. It's Leetcode 49 group anagrams, and it says given an array of strings, group anagrams together. Now let's define the word anagram. Anagram is a a word in which two words are anagrams of each other if they are just rearrangement of the same set of letters. Let's just say that way. So if each word is repeated exactly same number of times in the two words and they have the same number of words but the arrangement could be different, I think that's what is known as anagram. Now since we are talking about anagram, we might also talk about another interesting interview problem, which is see if a string is a palindrome. So palindrome is another beast which is mostly seen during interviews. And palindrome is that when you have a word that reads same backward, going forward and backward. So for example, a word like radar, radar, radar is usually is one example of a palindrome. Other examples of palindromes are, for example, things like well, I cannot think of any other words at this point, so let's not waste more time and let's do this problem. So group anagrams is looking good. The input is a bunch of words and the output is a list of lists, as you can see. And every list within the list will contain all the words that are anagrams of each other. So how do we start this problem? We are given and strs would be here a list of strings, list of words, and we have to return a list of lists, as you can see here. This is a cool Python 3 function annotations feature, which is kind of a little bit, I would say, useful because it tells you what are the different argument types and return values of the functions, like what happens in other languages where that is mandatory, for example in C or C++, I guess. In any case, so let's start coding, and we see that we have to return a list. So let's start by having a accumulating list where we would be adding this new list, and I think we would need a dictionary. This is a tip. This is a built-in Python dictionary where the order doesn't matter. By the way, in Python, dictionaries and sets are two sequences that are very useful, I would say. Or I would say they are not sequence. Maybe dictionary cannot be called as sequences because it's not order is not important in dictionary. But I would say collection. So dictionary and sets are two collections where the order is not important, and they are both supposed to give us the result in O1. So that's why it's good to know them. In this case, we will use a dictionary. So now let's start by walking each word in str. So for w in strs, we would what our approach could be, we can do one thing. We can sort the words in each w and then we look for its key in the that we use as a key for the dictionary. So the sorted word we use as a key in the dictionary, and so maybe it's a much better name for this variable might be word for word and strs. So what we do is we say, okay, if sorted word in dictionary in D, then life is good for us, because we can simply say that D, if sorted word in dictionary, then we say that so that is, by the way, this in D is basically, it will use this as a key, and it will look for that key in dictionary D. So then we can say D and then sorted word equal to, I would say, um, desorted word dot append, because what I was thinking is that each key would correspond to a value in dictionary, which would be a list, by the way, not a single value, not a scalar value. It's more of a list, I would say. So desorted word dot append word. Else, if else we would say, we would take the desorted word, and then we set to it that to we'll initialize the initial list with just the word. How is that looking? So at the end of it, we have a dictionary where the keys are the sorted word, and for all the anagrams the sorted word would be same, so they will all end up going in this dictionary on the same key, if not all, but all the ones that are anagrams of each other. So at this point we should see if these so we have to return the result now. So what we do is we create a temporary list, let us say, and then we say for k comma v in, so this is like, this is a typical way you walk a Python dictionary, for key comma value in D dot items, by the way. If len v greater than 1, or even if it is not greater than 1, for example here it is just 1, so that's fine. I mean, as long as we only worry about the list. So we say for k comma v in D dot items, so we basically pretty much do a temp dot append, and a temp dot append, I would say, for each item. Now see, even if it is the v is just a list of one item, that's fine. So then we may have to do a for anagram, or for word in v temp dot append word, right, for temp dot append word, and then when we are done with that, we basically append v into results. It's a result dot append v, and now let's not forget reinitializing temp back to empty list. So temp equal to empty list. I think there are other ways to clear a dictionary. I guess maybe Um, I think one way is that you basically probably you could do something like this. But basically this should also work because we are saying temp is back to being a dictionary with no elements. So at this point we're all set and we can return result. That should hopefully give us what we want. So let's run the code. So we have an error. He's saying you cannot hash things. Oh, I see your point. So what happens is that sorted actually returns a list of characters in words. So how can we take care of that problem? So maybe what we should do is we can have a temp here. So we can have a temp here which is sorted word. I would say join, maybe so we say dot join sorted word. How is that? So this returns us a list and then we join it on with no separator, and that gives us a word again which is sorted, and then we can say if temp in D. Or maybe it should have, you know what, it would have been nicer to have a name like sorted word variable rather than temp. So if sorted word in D, how is that? So let's try this now. Unhashable type. Again we have a problem. We should have here set sorted word. We still have a problem. Okay, we can fix that as well. Okay, so here what is the problem now? Is saying that built-in function or method object is not subscriptable. What is the problem here? Why the built-in method built-in function method object is not subscriptable? So temp.append is saying for kv in d.items. I guess I have spilled the coffee, so let me just fix this right now. Alright, so coming back to why is it's not for word in V, because V is a list for us. So for word in V, I thought that should have been okay. Is not subscriptable. What is V at this point for word in V? V is a list. I'm wondering why are we walking it again? If V is a list, why can't we just say result.append V? Why do we have to, or we could have here said result.append temp. That would have been much better. Than there's a problem here anyway, I guess. If V is a list, we can simply keep adding these lists into. Why do we need to have the separate temp build another list just to append? How is that one? Okay, so he's saying result.append V. Okay, result.append. I see a point. So basically we were making a mistake that we were trying to use that as subscript. Append we should be calling as a function. Sorry about that. So here we are. All right, that worked. So let us try to give it a shot by submitting and see if that passes as well. Cool. It's faster than 90% of Python 3 online submissions for group anagrams. That's cool. So that is pretty much the solution for this problem. But I would say if you are asked this question in interviews, how would you go about solving this? I think the most important thing is to understand that doing these kind of problems in C or C, at least in C, I guess C++ might still give you some basic primitives. Might be a little bit not as smooth, I would say, because in Python you get these built-in lists and dictionaries and things like that, especially the hash map, which is very useful in this case. So what is the insight for this problem? I would say definitely if you're going to group anagrams, building the list for all the anagrams to be in the same list, and if they're hash, if they can be found using the key. So the key, I guess, the most basic insight here would have been that the sorting of each word and making them fall for the same key and then adding them to a list. I think that is probably the most important takeaway lesson from this problem. Otherwise, it sounded like interesting problem, and especially if you have practiced these problems, it becomes much easier to solve them during interviews or similar problems. At least your concepts become clearer, and the things start to kind of click in your mind. So with that, I would leave you guys coding and having fun, and I would see you in the next video. Until then, enjoy coding. Bye bye.